All right, welcome. For a long time, you've probably been a guest in the digital world, staying within the lines that developers drew for you. Well, in this explainer, we're going to erase those lines. We're taking a journey from the web you can see to the invisible world of system security.
Think about it like this. In the web world, you're used to controlling the visuals, right? You can inspect element and change how something looks. But in the system world, we're going so much deeper. We're not just changing the paint job. We're learning how to control the logic of the machine itself.
So, our very first step is to move beyond the browser. We're shifting our entire focus from the document object model, the DOM, which structures what you see on a web page, to the actual system that makes it all run in the first place. We're going from visuals to logic.
Now, here is the core idea for this entire explainer. If you understand the CSS box model, you know how everything on a web page is just a box with padding, a border, and a margin? Then you're already halfway there. Seriously. Cybersecurity is just the box model, but for logic. It's all about understanding the containers and the boundaries that control how an entire system behaves.
And our main tool for doing this is the command line. Now, don't be intimidated. Just think of it like the console tab from your browser's dev tools. But instead of just giving you power over a single web page, it gives you access to the entire operating system. So you're probably asking, okay, how do we inspect element on the system then? Well, we start by asking it a question. See, in the terminal, every command is really a conversation, and we are about to learn our very first phrase. This is it, our first tool of exploration. I know it might look a little cryptic, but trust me, it is incredibly simple and unbelievably powerful once you break it down. So let's do that right now. Okay, let's break this down. The first part, uname, that's the command itself. It's just short for Unix name. It's basically our way of asking the system to tell us its name, to identify itself. And the second part, that little is what we call a flag. It modifies the command. And it's short for all, which tells uname that we don't just want one piece of information, we want every single thing it can tell us. So you put it all together, and uname minus a is just our way of saying, hey computer, tell me everything about yourself. Tell me about the kernel, the system, the whole shebang. Just like that, you stopped asking for permission and you started asking for the truth. Now to really get these concepts to stick, we need a good mental model. So let's imagine for a second that we're planning a heist on a maximum security bank. This is going to help us map out all the different layers of a computer system. So let's look at the layers. You see those shiny glass windows and the ATM out front? That's the front end. That's the website you interact with. Now what about the hallways, the air vents, the electrical grid that's all hidden from the public? That's the operating system, like your Linux or Windows. And the vault's inner clockwork, the core mechanism of the lock itself, well, that's the kernel. That's the very heart of the system. And this analogy also helps us reframe what a hacker really is. They're not some brute with a sledgehammer. No, they're a locksmith, an expert who understands the system so deeply they realize the vault uses a specific model of screw that, it turns out, can be opened with something as simple as a coin. They master the edge cases. Okay, now that we have a map of the system, let's learn its laws. Every world has rules, right? And in cybersecurity, the fundamental laws are what's known as the CIA Triad. Confidentiality, integrity, and availability. Let's break this down. Confidentiality, that's all about secrets. A web mistake like pushing your API keys to GitHub, that's bad. But a system breach like a packet sniffer reading passwords over Wi-Fi, that compromises user data directly. Then there's integrity, which is all about trust. Sure, you can change your bank balance in DevTools, but it's just a visual trick. An SQL injection, on the other hand, changes the actual value in the bank's database. That's real impact. And finally, availability. That's about access. A rogue JavaScript loop might crash your browser tab. Annoying, right? But a DDoS attack can crash the entire server, making a service unavailable for everyone. You see? The stakes are just so much higher in the system world.
All right, now for the final piece of the puzzle. This is the insight that separates a student of security from a master architect, and it's all about a simple shift in perspective.
And it all comes down to this one simple question. A real expert doesn't just ask if a piece of code is buggy, they ask if the fundamental logic of the entire system is flawed. And this is the crucial distinction. A junior mindset looks for broken code, bugs, obvious errors. An expert mindset looks for broken logic. Here's a perfect example. The code on a forgot password page might be totally flawless. But if that page confirms whether or not an email address exists in the database, well, the logic is broken. An attacker can use that feature to discover every single user of your service.
This analogy just says it all. Security is a weakest link game. That fancy, expensive, high-tech door is absolutely useless if an attacker can just stroll through the paper-thin window right next to it. Experts don't just look at the door, they examine the entire building.
And that's really what this is all about. Everything you interact with, a website, a bank, whatever, it's just a stack of layers. Most people, they only ever see the top one, that shiny interface. But after this, you're going to start seeing the wires underneath.
You've learned that cybersecurity isn't some kind of magic. It's architecture. You've seen the layers of the building, and you've learned its fundamental laws. You've even asked your first question to understand its structure. So the blueprints are on the table. The only question left is, are you ready to read them?